Alright, welcome back to question 5 of the 2012 FRQ for the AP Calculus. Problem reads as follows. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. At time equals 0, when the bird is first weighed, it weighs 20 grams. If B of t is the weight of the bird in grams, and at time t days after it was first weighed, then dB over dt equals all that stuff. Okay, so it's a nice little twist on an otherwise standard differential equation problem. And so it says, let y equals b of t be the solution to the differential equation above with the initial condition that b of 0 equals 20. Okay, so part A, it says, is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your reasoning. Okay, well, let's go ahead and find out exactly what's happening here. Part A, well, remember, dB over dt is the rate at which that bird gains weight. And so I want to know if the bird is gaining weight faster or if dB dt is bigger when the bird weighs 40 grams. All right, I want to find out what that number is. And I'm going to find out the exact same thing, except this time the conditions are under which the bird is 70 grams. Okay? So what does that get me? It gets me 1/5 times 60. Here it gets me 1/5 times 30. Okay? So that's 6 and that's 12. So therefore we can say the bird is gaining weight faster when it is 40 grams. Boom. That's it. 12 is bigger than 6. That's all we need to know. So part A is relatively straightforward. Next part B, is a little bit confusing. It's strange. Well, I'm going to go ahead and find d squared b over dt squared. So what I get, let me switch my tool here. I'm going to go ahead and derive it again. So d squared b over dt squared is the second derivative, or the first derivative of this guy. So what I get is I get 1/5, right? Kick that out, times a negative dB over dt. So if I take the first step at simplifying this out, what I get is negative 1/5 times dB over dt. Well, what was dB dt the entire time? Well, it was the equation that they gave to us in the beginning. So I get negative 1/5 times 1/5 times 100 minus b. So to fully simplify this thing, I get negative 1 over 25, 100 minus b. Now, what they're asking me is actually a little bit more complicated. It's saying, explain why the graph of b cannot resemble the following graph. And they're talking about this graph right here to the right side. They want to know why this cannot be b of t. So I'm going to go ahead and say, not b of t. I'll put a question mark next to that, because it's why. Why can't it be that? Well, let's look at the graph on the interval from 20 to 100 on the y side. And we rarely ever do this, but I'm going to just draw out a condition for you. If b was in between 20 and 100, that means that this piece right here, the 100 minus b, will always positive. That's a problem, because if this piece is always positive, being multiplied by the negative 1 over 25 means d squared b over dt squared is always negative. And what do we know when a second derivative is always negative on a given interval? Well, that means B is concave down on B being between 20 and 100. However, the above graph is sometimes concave up. Therefore, B cannot be the above graph. Okay? And again, it's really because this portion here between 20 and 100, which is the portion that we're looking at right here, right? All these x inputs are going to give you some kind of output in between 20 and 100, which means some kind of x input right here is going to give you a concave up graph. There's no way this thing is concave up because it looks like between B, the y-axis, being between 20 and 100, we're always supposed to be concave down. So there's no way that this graph could be representative of B based on the second derivative. Hopefully that makes a little bit of sense. Let's go ahead and move on to part C, the final part. Use separation of variables to find B of t, the particular solution to the differential equation, with the initial condition being B of 0 equals 20. So let me clean up the board here real quick. Alright, let's go ahead and separate some terms and get ourselves into a good position. So, if I know that dB over dt is equal to 1/5 times 100 minus b, the first thing I'm going to do is I'm going to separate all the terms. So I'm going to divide out the 100 minus b from both sides. And then I'm also going to move the dt over. So what I've got is dB, oops, I've got 1 over 100 minus b dB is equal to 1/5 dt. So how do I go from here? I'm going to integrate both sides here. I'm going to integrate, and what I get is I get the natural log of 100 minus b, but I also have to remember that if I derive this thing, a negative will chain out via chain rule. So I'm going to go ahead and just account for that negative by reversing the negative here. And what that gives me is 1/5 t plus c. Now at this point, I know this thing is going to turn into an exponential function. So what I'm going to do is I'm going to go and just solve for everything like I normally do, and then I'll solve for c later on. So what I'm going to do is I'm going to go ahead and multiply both pieces by a negative. So I get ln of absolute value of 100 minus b equals negative 1/5 t plus c. Okay, from here I'm going to go ahead and keep on moving. I'm going to go ahead and call this 100 minus b is equal to negative 1/5 t minus c. I went and just distributed the negative. From here I'm going to go ahead and change forms. So what I have is 100 minus b is equal to e to the negative 1/5 t minus c. Okay? Now from here, why would the absolute value function go away? Well, it's because, remember, look at the initial condition here that they gave to us from the graph. We know that 20 is less than b, which is less than 100. So b is less than 20 and 100. Oh, sorry, b is in between 20 and 100, which means this output here is always going to be positive. So we can just go and let the absolute value kind of go away from here. From here, I'm going to call this e to the negative 1/5 t times e to the negative c. E to the negative c is c e to the negative 1/5 t equals 100 minus b. From here, I'm going to go and solve for c at this point. Well, what were the initial conditions? When b of t equaled 0, when t equaled 0, b equaled 20. So let's solve for c. 100 minus 20 is equal to ce to the negative 1/5 times 0. That portion here goes away. C equals 80. So what I have here is, if I go back to this diffie portion here, what I have is 100 minus b is equal to 80e to the negative 1/5 t. Now I just got to get b by itself, so negative b is going to be 80e to the negative 1/5 t minus 100, which means b is equal to negative 80e to the negative 1/5 t plus 100. And there you go. There's your diffie about the baby bird. Alright, we'll see you guys in the next problem.